So I'm going to be talking about deliver the developer experience even. Human beings typically make an assessment within about 5 seconds, so hopefully you've noticed a few things about me that mean that I've got some experience and I can relay from that some stories and some anecdotes around what's been happening more recently. I was extremely lucky. Back in '85, I was the 4th employee of what would now be termed a startup. And so I got to play with a lot of technologies because we were inventing and innovating within a particular marketplace. With ThoughtWorks for the last 14 years, I've been working with some larger enterprises. And in that context, it's quite often those experiences from the 80s were not really what I was experiencing within the wider, larger organizations. There's a lot more in those organizations that constrain a developer. And quite often, this is a stock photo, and that's quite often the only smiling face that you might see within an enterprise for developers, as they are constrained by the environment that they live in. And those constraints are perfectly valid in some senses. If I think about what's been happening largely over the last few years in terms of security and security breaches, security is a key piece. It's been around for a very long time. Those that have not, those that want what other people have. And we've set up security. It's been a theme for hundreds of years. In fact, one of the key examples might be the Great Wall of China, where China wanted to protect itself from the rest of the world. And that's one of the largest walls. So we've been using walls either as a single wall or as it was innovated in various countries, rings of protection to keep the inside safe from the outside. And whatever that gap is, we want to keep the inside safe. Here's a very, very simplified wall. It might even be a moat, some barrier between the inside and the outside. And if you can imagine that the world, the internet, and all of us are currently on the outside, and inside that ring is the enterprise. And that's the pieces that need to be kept safe because there are bad people outside who want the things inside. And even if they're not bad people, letting them have their data inside might encourage them not to be good. So we have our wall, a typical networking, firewalled possibly, with a proxy to keep traffic monitored. If you're in a regulated environment, it's quite often have a proxy that keeps the inside separated from the outside. And the first thing we need to do is to keep our data safe. So we put our data inside our wall. Now that data needs to be managed, and our systems that interact with that data also needs to be maintained, managed, and monitored. So we have our Happy Ops team. And our Happy Ops team are working there inside the wall, and they're maintaining and ensuring that the systems are running. Walls have typically been expensive. Think back to the Great Wall of China, that took hundreds of years to build. And even with our software-defined networking, typically our IT information systems in the enterprise are also expensive. So we want typically to have a small number of walls, and that's where most people live, I think, in a small number of outside and cascading walls. So we put everybody else in here. And we have our code, our source code. It might be sensitive. We also have our developers. And we have our knowledge bases. Now this is one kind of protection. The advantages are everybody is in the same pot. Everybody lives the same life. Challenges are that a business operations group has different requirements from a technical development group. And so our developer is not exactly the happiest person. And we have this sort of mediocre experience. Also, because we have a proxy, we might have external information systems, but we're worried about what's in those information systems. So when someone goes to look at those information, it bounces off. It's not allowed to come through that proxy or through that firewall. And so the developers within this environment who are looking externally, we're looking for that information to share and to collaborate internally to innovate based on other people's work. They don't have access. And this can lead to some anti-patterns where they might do home research and bring the knowledge in. They're going to get that information anyway, but it's not in a controlled and managed form. So what can we do about this? I was working with a client recently, and this was a significant problem. It was a regulated financial organization. It has lots of very valuable data that needs to be protected, but also is trying to bring in innovation. That organization needs to move faster and faster, develop software, learn from others. It needed to be in a completely different space. So what we did and what we talked about and what we started to develop was the idea of two. So we would bring in a second wall. And in that second wall, we would have different rules. So the rules of the operations group and the rules of the development group were separate. And between those two, there was an air gap. Now, there are various regulatory controls that require things to happen in the dev side to make sure that access is controlled, access can be revoked, and that added some complexity to the two-wall approach. But it did mean that moving the developers over here, they're now in a separate space. They can look through glass-type systems, Citrix, etc., to look at anything on the corporate side, whilst being able to live in their own separately controlled world. Now, if we put the developers over there, they need their code. So the next thing to bring across is the source code. And so having that, they can now start working with that code. We also need different information to be available in the two groups. So information gets separated, but we also need the code to move into the enterprise and get into production, because if we can't deliver into production, then we're not actually delivering value. So in this context, we have a developer environment in a separately regulated zone, in a separate network, air-gapped with production, that allows the developer access to different information sources in a different way on the outside of that network. They can be more relaxed. They can start to bring in tools and techniques that they want to try out and experiment with. If you've ever been part of an architectural approval board where you need to work out what you want, then ask for it to come in so you can then experiment with it and then discover it's not what you want to use. It's a very long cycle. The reason for that is that in a single network, those items have to be approved because they're coming through that security barrier. They need to be reviewed, they need to be checked, they need to be monitored. Having a separate environment means that the enterprise is safe from that infection, and we can bring things in and there's very little risk in it transferring, because the only thing that we transfer from one network to the other is source code. We can define our pipelines, we can define our networking, etc., and it comes through a very auditable ingestion point. Pull from that developer network rather than push from the developer network. So it tends to be on a time cycle, but by bringing in source code that defines the pipeline and the path and the execution means that we can operate in a very effective manner on one side and have the stability and the protection on the other. And source code being text is, and we know that there are many scanners, etc., that can protect us from version upgrades, inadvertent version upgrades, and it becomes more of a managed, discrete transaction between the two groups. So in this context, we have a much happier developer, being able to work and have a different experience from working within the more protected network. So we keep up our separation. We have the enterprise needs to protect and serve its customers and maintain that stability and availability, and developers are able to innovate, experiment, collaborate, because they're operating in different information space. That's just one change or one effect that we can make by making that separation. But let's say that that separation is not possible in your context. In many traditional enterprise organizations, with matrix organizations, or even working on many services, the organization starts to decompose the information and the boundaries between groups so that we end up with many different pockets or cubes of data. In this context, it's very difficult for a developer in one space to actually know what's going on in the space next door or a space around the world. Everything is compartmentalized. Source code repositories, etc. So you quite often hear questions like, what is X? What does it do? And how does it work? And these are sort of typical questions that you get in the larger organization where you've got all your services decomposed into repositories. The access control on my repository is just different to the access control on another repository. A can't see B. You don't even know it exists. So when it comes up in a log message, it becomes really quite odd, particularly on an incident. What is this system? I've never heard of it before. How do I find out about it? This information siloing is counterproductive. It causes a lot of extra work. People create systems as a requirement for asset management. And those systems quite often become the truth. And they are also partitioned on security, knowing who knows what is going on in there. And so we still don't have a method for discovery, just automatic learning, just to be able to find out when you hear something, oh, I wonder what this system is, and to be able to explore. So I think one of the key parts to having a good developer experience is that developers can find out what there is, what it does, how it works, so that they can look at taking things that work elsewhere, share that knowledge, do evolutionary reuse or emergent reuse. So discover things that have been done by other teams, which are probably fantastic and might be applicable in their space. So adding discovery to the mix allows developers to be able to find out what is going on in other spaces. And recently I started working on this with a couple of expectations. First of all, we needed to open up I think it's about 7 or 8 different wiki systems, because of course each group likes their own wiki. Each one has a mine of information from the last decade, which is useful both for business and for tech. So the first thing we introduced was a web search, a crawler, that would go around and collect this data into a secured web search system, which meant that if you suddenly had the idea, what is X, you could actually search for X. And it would tell you and point you to the information sources for X. Code siloing. Move to a default of read-only access. Now, because of the leakage or the partitioning of information, there's quite often things that need to be cleaned up in the repository. But moving to a read-only approach means that people can have access. The problem is they don't necessarily know how to have access. So introducing something like a code search tool means that developers can look both at information that is being shared by other groups or used within those groups on a wiki to keep a project coordinated, but also to be able to explore the wider code base, to find out how people are working with particular problems and how they've solved them, to see whether they can learn from each other. And at the very least, want to know who worked on this so I can go and have a conversation. So combining those two things together give an element of discovery. Developers can explore the overall ecosystem of the enterprise to know where things have been done, what they are, how to change them, how to submit pull requests or make other changes, but also to discover how things have been done, to be able to get that sort of collective learning. So I'll just reiterate, there we go. Make things more read-only. Read-only is probably the first step to being able to open things up. If it's read-only, people can find it. There's a possibility. Make it discoverable. Move things to complete. So if you're using a story management system, requirements management system, think about linking your systems together, integrating them, so when a developer makes the first commit on a story or feature, automatically move that requirement into development. Then when it hits production, say it's complete. We have released it. We have less work to do, and through automation we can actually bind working practices together, as well as bind systems together that makes a more effective working environment. A thought to drive a number of these changes is that recording an audit should happen as a result of what we do, not the other way around. So the processes and the systems that we use should not be the drivers for the work that we do, but the work that we do should reflect and record automatically as part of our systems and transitions. And maybe we'll be able to turn a stock photo of a smiling developer into a real one. Thank you very much.